Right, year 10, we're going to introduce your next assessment, which is the investigation. Mr. Baptist and I are just going to give you a bit of a rundown in case you weren't here for the lesson that we introduced it to your class. If you think about two cars driving along the road, one going at 60 k's an hour, one going at 100 k's an hour, something moves out in front of them. Which one is going to be able to stop fastest? Which one is going to take the longest time to be able to stop? Okay, obviously the one going slower is able to stop faster. The one that is going faster has a greater amount of energy. It's got more momentum. So we need to consider that in this investigation. What you're going to be doing is getting a trolley that has very little friction. So the wheels are designed that we can ignore friction. And we're going to run this down a ramp at 3 different angles. So if we think about that being our ramp and that being the floor of the basketball court, which is where we're going to carry this out, we put our trolley up at the top. Okay, we let it go. Up here, it's got what sort of energy? It's got potential energy, okay? So that's energy due to its position. And the formula for potential energy, you might remember from year 8, is mgh. And we'll talk about what mgh stands for a little bit later. When you let that go, at the bottom of the hill, okay, that potential energy has then turned into kinetic energy. So up at the top here, before you let it go, it has potential energy. It hasn't got any kinetic energy because it's not moving. Once it hits the bottom of the ramp, then the potential energy is 0 due to gravity because it's at ground level. All of that potential energy we can consider has turned into kinetic energy. Okay? So all that potential energy has been converted into kinetic energy. We assume that because of the good design of these trolleys, friction is minimal. We ignore air resistance, etc. So the formula for kinetic energy is a half mv squared, and we'll again talk about that a little bit later. What we're going to do is start up dropping or letting the trolley go and measuring its stopping distance. Now remember, we need to measure the stopping distance from the bottom of the ramp to wherever it stops, okay? Not from the top of the ramp. We need to go from there. Then, you're going to obviously repeat that 3 times for your 3 trials. We're then going to lower the ramp a little bit, say to that angle, place the trolley at the top, let it go, and we should get a slightly shorter stopping distance because it has less potential energy right at the beginning. Therefore, it would have less kinetic energy at the start of the stopping distance, if you want to call it that. 3 trials on that one. Then drop it down to the lowest height. Okay, and again we should get a slightly lower or shorter stopping distance there. 3 trials for that. So we've got 3 ramp angles or ramp heights, and we've got to measure the height of the ramp in meters. So we're going to measure that for the first one, the same position down to the floor for the second one, and in the same position down to the floor for the third one. That should be in blue. Okay, so we've got the 3 heights for the 3 different ramp positions, and we end up with 3 different stopping distances. And basically that is what you're doing. That is all the practical work you have to do. On your sheet, if you turn to the page that has the results table on it, you're going to see that there's space for 4 trials, not 3. Reason for that is what? Think about what might go wrong. Okay, I'm not going to give you the answer to that. You don't have to do 4 trials, but you might need to do 4 trials. There's also 4 rows for results. Again, you might not need to. If you do everything right the first time, you'll probably only need to do 3 trials at 3 angles. If something goes wrong, you've got a bit extra space. Mr. Baptist, what have I left out? Do you want to stop it for a while?
Yeah.
Cool. What have I left out? Right, Mr. Baptist has just pointed something out to me. Thank you. What I should show is that the floor obviously extends along here, and these arrows should be going obviously all the way down to the floor. The other thing is, my drawings are not really good, but make sure, we're talking control variables, make sure that you place the trolley at the same position on the ramp each time, and that you measure the height from the same position on the ramp each time. Okay, so down to the floor but from the same position, and obviously your wheels are not going to be hanging off the end, you're going to have it at the edge of the ramp that you make. We're actually going to be using bench protectors as our ramps because they have a small lip and it doesn't cause a problem when the trolley hits the end of the ramp. There isn't a big jump for it to do. We're going to use that with blue trays to change the angle of the ramp. We only need small angles, and I'll show you in a little while why. The next thing I just want to talk about now, this is mainly for those of you who are intending to do Year 11 physics. We want you to include this in your table of results. Those of you who don't do it, you obviously will lose a few marks, but if you understand it, do it and get some help about it. So when we're talking potential energy and kinetic energy, what we could do, we could work out what the potential energy of this trolley is. MGH, M is, I'm going to use a different color, M is the mass of the trolley, and that is in kgs. G is the acceleration due to gravity. Since we're doing all of these experiments on Earth, that stays at 9.8 meters per second squared. It doesn't change. That would be different if we went to another planet. We don't have that problem today. H is the height of the ramp, and again that needs to be in meters. So we've got kgs, meters per second squared, and meters. We've got to keep our units correct. So we could work out the potential energy that that trolley has at the top of the ramp, and then we know how much kinetic energy it's got, and we could then use that to find out what its velocity is at that point. And then we've got different velocities for different heights because h is changing, and that would lead to different stopping distances, different velocities, different stopping distances. We can simplify it because we're saying that all of that potential energy changes into kinetic energy. So if all that potential energy changes into kinetic energy, we can say that potential energy equals the kinetic energy at the bottom of, so potential energy at the top equals kinetic energy at the bottom, so that mgh equals a half mv squared. Okay? Now let's simplify this. We want to find out the velocity. The velocity is what we're looking for. We've got m on both sides, so we can take that out. All right? I need v equals something. So we rearrange this. I'm going to do it in a few steps just so that it makes it easier to see. If I multiply through by 2, I get 2gh equals v squared. I'm going to swap them around. V squared equals 2gh. Therefore, v equals the square root of 2gh. All right? You know what g is. G G is always 9.8 meters per second squared because we're staying on Earth. H is the height of your ramp in meters, and therefore you can find out what the velocity is, right? That is an extra column you're going to need in your table, especially if you're planning on doing physics next year. Okay, I would like everybody to do it, but I know that some people might be a little bit scared off by that. Mr. Baptist, what else do we need to tell?
I think that's
About it.
sufficient. Yeah, so that covers everything.
Okay, I'm going to just demonstrate how to set up the ramp quickly. Okay. Do you want to just pause it, please? Okay, now we're just going to show you how we suggest you set this up. Some of you may have access to the proper ramps, but honestly, I think this is an easier way to do it. You've got 2 or 3 trays. Share them amongst the rest of the class because they're limited number. And you've got one of these nice thick bench protectors. Some of them are thinner wood and they bow. Make sure you get a nice flat one. You've got a trolley, expensive little item because it's got very little friction in those wheels. And each group gets a 30-meter tape. Okay? Please be really careful with all your equipment. We will put you into numbered groups, and you've got numbers that match your group number on your equipment so that we know if somebody has accidentally messed something up. When you put this back in again, please make sure that you don't twist it in. So you've got to put your fingers here, hold it when you wind it up to make sure that it goes in nice and flat. Okay, so take care of the equipment. First thing you need to do, we'll be out on the basketball courts. I suggest that the first height is just one of these blue trays with the ramp, the board propped up on it. If you've got a nice smooth one, use the smoother side. If that's got lots of stuff on it, roll it over and use the other side. Okay, this one had too much the other side. Place your trolley. Note how you're going to start it, where you're going to start it, who's going to do the starting, how do you release it. Think about controlled variables, really, really important. Set it up, you let it go, and then you measure from this point to where it stops. Second height, so you must, before you take it all apart or when you've set it up, measure the height. Just use a ruler, it's a lot easier than the tape. Second height, I suggest, is just put another tray on and prop it like that. Again, set up your trolley, let it go. Now you can see that this just gets there without the front end digging into the floor. You might find that yours is a little different. Make sure you're not having this hitting. It's got to run off the side. The next, or the third height, which is actually the middle height, is probably going to be something like that. So you've got the 2 trays in there, and that runs nicely. Okay? Don't make it any higher than what we just had it because of this problem hitting the ground, and this will give you nice long stopping distances anyway. I think that's it. Thank you.